In this video, we're going to take a look at operations with polynomials. Specifically, we're going to look at how to add, subtract, and multiply today. So as far as a polynomial goes, our definition of that could be a monomial, which remember mono as a prefix would mean one. So a monomial is a polynomial with just one term. And it could also be a sum, which means addition, right? Or a difference of monomials. So that would mean subtraction. Okay, and then we have these polynomials made up by what I called monomials, meaning a polynomial of one term. Well, we need to know what a term is. So when you look at a string of monomials together, so maybe it's something like 4x squared, where you have a coefficient and a variable term, but no plus or minus sign. As soon as you start putting plus or minus signs in, we are creating separate terms in our polynomial. So for instance, if we're looking at an expression that has two plus signs in it, we would say that those plus signs are dividing into separate terms, and so we'd be seeing three terms. We'll get a look at that very soon. Look at prefixes down here. There are two common words that we should be able to use as we speak about polynomials. Binomial, that prefix bi means two, and so a binomial would mean that you would expect to see two terms in your polynomial. And for the same idea here, tri meaning three. So trinomial, three terms. And there might be some other names after that. They're not very common. So as far as words that we want to know, they would be monomial, binomial, and trinomial for one, two, or three terms. Okay, so what we do quite often, and we'll see that later in the year, starting in January more so, but we'll talk about polynomials by their exponents that they have, and a lot of times we'll refer to polynomials based on their exponent. So when we see x squared, that's something that's familiar with us. This is called a quadratic expression. I know what you're thinking, quad usually means 4, but for us quadratic would mean that you see x squared, an exponent of 2. And x cubed would be a cubic. That one's pretty similar to how we read x cubed. So if we can read x to the third as x cubed, we can call this a cubic function instead. And a lot of that's going to roll in either at the end of this semester or starting the next one. So what we're going to start off with today is just adding and subtracting. And this is something that we've done in the past, but we'll still refresh here. When we add and subtract, essentially all we are doing is combining like terms. And so as we do that, to know what terms can go together, we look at the terms and we want to find the ones that have the same variables. So if you see x's and y's in a term, then you need another term that has x's and y's. And those variables have to have the exact same exponents on them. So if the x has an exponent of 5, we must have another term with an exponent of 5. Okay, so let's take a couple look at these. Case 1 here, we see parentheses showing here's our first polynomial, and if you look, there's a minus sign in it and a plus sign in it. That means that we have 1, 2, 3 terms here. So that's what we mean by terms. When you have a minus sign, a new term is made. So this is a polynomial with 3 terms. That's called a trinomial. And you'll see over here, again, inside these parentheses, we have a plus sign creating a new term and a minus sign creating a new term. And we have 1, 2, 3 terms again. This is another trinomial. Okay, and so what we see is that we have two trinomials that we're trying to combine through addition. That's why there's this plus sign right in the middle. And things about addition is pretty basic because we do not have to worry about any signs changing from a plus. A plus sign will not change any values. And so essentially here, when we see situations that have addition in the middle, we can pretend that the problem didn't even have the parentheses to start with. So let's rewrite this scenario without those parentheses, 3x squared minus 2x plus 3. And then we're going to add x squared, and we have the plus 4x, and we have the minus 2. Okay, and what our goal to do at this point is simplify as much as we can, which would be combining like terms. And so as far as doing this, we said look for the same variables. So we see a lot of x's all over the place, but we must have the same exponent too. So we see an exponent of 2 on this term, and we also see an exponent of 2 on this term. So we have 3x squared plus, remember this is a 1x squared, and that is what we're going to do. We are essentially, and I'll write it out longhand this time, but never again would I do this. I'm going to put the like terms together. So we have a 3x squared plus 1x squared. We also have this minus 2x and a plus 4x that we're going to combine. I'm just going to write them down here together so we can see it a little bit better. And then lastly, we also have a plus 3 that has no variable, a minus 2 that has no variable. That makes them like terms that can go together. So normally I would skip this step, but this gives me a visual. These green terms, these x squared terms, are supposed to be combined. And so what I'll do is I'll just calculate what we have. We have 3x squared plus a 1x squared. Very simply, we add the coefficients and leave the exponent the same. So 4x squared is what we'd get. After that, we have the minus 2x and the plus 4x. Same deal, negative 2 plus 4 is positive 2x. And at the end there, we have plus 3 and a minus 2, which is simply just plus 1. And you can take a look here. There are no more like terms to be combined. So this would be our final result. 4x squared plus 2x plus 1 is what we get when we add these two trinomials together. Okay, so that's a case of addition. We're going to apply the same idea to subtraction. Now, the only difference with subtraction is minus signs do affect us because minus means negative. And so you see a little note over here that says distribute, and there's an arrow pointing at that minus sign. So what we need to pay attention to is where the minus sign is located. In this case, it's in front of our second polynomial. And what we'd need to do here is we need to distribute a negative 1 inside parentheses. Now, thinking through what that actually does, multiplying a number by negative 1 really just changes the sign. So as we take this negative 1 times this negative 3, we're just going to be left with a positive 3 instead. We take our negative 1 times a positive 3, and then we get a minus 3 instead. And lastly, a negative 1 times a positive 2 would just give you negative 2. So we're just changing signs. We are not changing variables or exponents from this. But in front of the first parentheses, there was nothing but a positive 1 there. Multiplying by positive 1 does nothing. 1 times 2 is still 2. 1 times 5 is still 5. So it's not the positive ones we need to worry about. It's the negatives. So subtraction, we'll just make sure to apply that minus sign to all terms, but the first 3 stay the same. And we get 2a cubed plus 5ab squared minus 7. And just like before, we want to combine like terms, which would allow us to say we have simplified. So what we like to do is we like to find the highest exponent first in alphabetical order. So as far as a's and b's, a is first in the alphabet, and I see that the highest exponent on an a would be this 3. So we have a to the third in this term. And I'm going to see if we have any terms that match that, and if we look over here, we do. So we're going to combine these two terms, read what they say. That is 2a cubed plus 3a cubed. 2 plus 3 is 5a cubed. Okay, and so I'm going to look around again for the highest exponent that we have on a. Next highest exponent, we have a to the second right here. Okay, so a to the second. I'm going to see if we have any others with a to the second. And if you look, we are tempted to choose this one, but this doesn't have a to the second. This actually has a to the first. So these two are not like terms. We have the same letters and that same exponent of 2, but the 2 was on a in this term, and it's on b in this term. So the exponents are not matching where they're located. So we have no like term to combine with this minus 3, a squared b, so we'll leave it exactly as it was. And likewise, we have no like term for this plus 5 ab squared, so we will leave it as it was. And lastly, we have a minus 7 with no variables and a negative 2 with no variables. They can be combined. Negative 7 minus 2 is negative 9. And just like before, there are no like terms down here. We have simplified our expression that this is what we get when we subtract those two polynomials up top. So in a nutshell, adding and subtracting is pretty basic, just in the sense of all we are doing is adding or subtracting coefficients. We don't have to change any exponents or variables. We're just adding the coefficients or subtracting the coefficients, and we'll be careful in subtraction. We'll make sure to take the minus sign all the way through a quantity. But that's all there is to adding and subtracting. So the only thing we really need to cover now is multiplication. And honestly, multiplication isn't as bad because you don't have to worry about setups, rearranging terms. Very much all we are doing is multiplying. And we need to talk about how to multiply. So we have three different cases down here I wanted to walk you through. First case is, you might notice that we have a quantity, negative 2y squared, that's in front of parentheses. And we've talked a long time. When you see a number in front of parentheses, you're supposed to distribute it. So we'd take negative 2 times x and negative 2 times negative 4. Well, we're still going to use that distributive idea. It's just this time we have a number negative 2, but we also have a variable y squared that we're going to distribute to each term. So we're going to use our exponent rules that we've previously discussed to help us through our multiplication. So to get started, we'll take negative 2y squared times 4y to the fourth, and essentially here's what's going to happen. We're taking this negative 2y squared times this, 4y to the fourth. I'm going to write it out longhand this time. And then we're going to take the negative 2y squared times that middle term. So negative 2y squared times 2y to the third. And lastly, we'll take our negative 2y squared times negative 3y. Okay, so we have distributed the monomial negative 2y squared to all three terms in our parentheses here. And we just need to simplify to finish this up. So when we multiply here, we multiply coefficients together. So we take negative 2 times 4, which is negative 8. We'll take y squared times y to the fourth. And our exponent rule says when you take a y times another y, you are supposed to add the exponents. So 2 plus 4 is 6. In the middle here, we'll do the same things. Negative 2 times 2 is negative 4. Y squared times y to the third. We are supposed to add the exponents. 2 plus 3 is 5. And at the end, a negative 2 times a negative 3 should give us a positive 6. And y to the second times y, which is y to the first, remember. Y to the second times y to the first, add those exponents. 2 plus 1 would give you y to the third. And if you look, no like terms because all of the y's have a different exponent. So we've officially simplified this expression. Now, also note that you don't have to do this step in blue up here. You could, if you're comfortable enough, just go from distributing the negative 2y squared to each term and writing the result down that I have here in red. Okay, so that's a case of distributing just one term. Now, when we look at number 4, we see that there are two parentheses being multiplied. So we learned a long time ago that multiplication means, or parentheses mean multiplication, and we should know that we're supposed to multiply what's inside one set of parentheses with the other set. The issue here is we don't just have one term in these parentheses, we have two, right? This plus sign makes two terms. So this is a binomial. And so we need to talk about how do we take a binomial times, over here we have two more terms, another binomial. So if we go back to this idea of multiplying what's in one set of parentheses to the other set, I think we'll have a good idea of what's going on. Because in here we have two different things. We have a 2a and we have a 3. And essentially what we need to do is we need to take 2a times both terms over here, and we need to take 3 times both terms over here. So easy way to go about this is just take 2a first times both of these things. So we take 2a times 4a. So I'll write it out longhand again. And we need to take 2a times negative 1. So that's a positive 2a times a negative 1, which would be multiplying 2a times that second term. And so we've officially taken 2a times both terms over here. We need to do the same thing with our positive 3. We need to take positive 3 times both terms over here. So it's the same idea. Now we just need to take this 3 times the 4a, which would give us, I'm running out of room, so I'm going to write it down here, plus 3 times 4a. And then we need to take the positive 3 times the negative 1. So plus 3 times negative 1. And if you look, it looks like we took everything in the first set of parentheses, the 2a and the 3, times everything in our second set of parentheses, the 4a and the negative 1. So we've officially multiplied the two parentheses together. What we need to do is we need to simplify this. So we need to take 2 times 4a, which is 8a. And then we need to take the 2a times the negative 1. That would be negative 2a. Uh-oh, I just saw a mistake up here. This, I just wrote down a 2. That very first step, we were taking 2a times 4a, not just 2. 2a times 4a was the very first thing we did. Sorry about that. So if we fix that then, 2a times 4a is 8. A times a would be a to the second, because both of these a's have an exponent of 1. Okay, so this other term was fine. 2a times negative 1 is negative 2a. Next, we take the 3 times 4a. That's plus 12a. And we need to take 3 times negative 1. That's negative 3. The only thing left for us to do is decide if we have multiplied everything together. Now, I'll also note that once you get comfortable, what I would typically do is I would just go through this multiplication up here and jump straight down to this step, writing down what I get from it. So that's perfectly fine. And notice that when you take two terms in one set of parentheses times two terms in another set of parentheses, you end up with 4 terms. Kind of makes sense. 2 times 2 is 4. And we'll apply that rule again. But we are not simplified yet, because if you look in the middle here, we do have these two terms that have the same variable with the same exponent. We can combine those. Those are like terms. So to simplify this, we need to combine those terms. We'll still have 8a squared in the beginning. Negative 2a plus 12a is plus 10a. And then we have a minus 3 at the end. Okay. And that is totally simplified. There are no like terms left. This is what we get when we multiply those two binomials together. All right, so let's try this one more time. Now you see 5 is slightly different than 4 because we don't just have 2 terms here. We have 1, 2, 3, right? So 3 terms here. And in the second set, we just have the 2 terms. Now let's think this through. When we take 3 terms times 2 terms, if we do this all correctly, we should get a total result of 6 terms. Okay, so if we multiply correctly here, we should end up seeing 6 terms created through that multiplication. So let's use the same idea as we did before. Let's take y squared, let's take everything in this first set of parentheses, so the y squared, the 3y, and the negative 4. Let's take everything in these parentheses times everything in the other parentheses. So if you just want to be very systematic about it, start with your first term here, this y squared, the first term that you have, and go multiply it to the other set of parentheses. So we have y squared times a y. And remember, this is y to the first. So y squared times y to the first is simply y to the 2 plus 1. That'd be y to the third. And we do this again. Y squared times 2 would be plus 2y squared. And just check that out. We took y squared times both terms over here. I can follow my arrows. Y squared was multiplied with both terms in the other parentheses. So we move on to the next. Let's work with the 3y. Let's take 3y times the terms in the other parentheses. So we take 3y, which again, remember, that's 3y to the first, times y to the first. So we still have plus 3. There was no coefficient over here we needed to multiply with. It was just a 1. But we need to be careful. Y to the first times y to the first is y to the 1 plus 1, so y squared. All right, so if you look, we haven't multiplied 3y with everything over there yet. We still need to take the 3y times the 2, which means we just need to multiply our coefficients together. 3 times 2 is 6. And we still bring the y with it, so we have plus 6y. So 3y times 2 is simply 6y. All right, and lastly, we need to take -4 times the terms in those parentheses. So we need to take -4 times y, which is -4y, and -4 times 2, which is -8. And like I told you, when you take 3 terms times 2 terms, if you've been systematic about it, you should end up with 1, 2, 3, 4, 5, 6 terms. So it looks like we've multiplied everything together that we should have, meaning all we need to do to simplify is combine like terms. And the easiest thing to do is when you start getting a lot of terms in a string like this, start with your highest exponent. So we have y to the third up here. I don't see any other y to the third terms, so we leave that one the same. Let's go to our next highest exponent. We have y to the second. And if you have others that are y to the second, like this one, we'll combine those. So when adding exponents, all we do, remember, is add the coefficients. So 2 plus 3 is 5, and it's still 5y squared. We tend to get confused after we've changed exponents through multiplication, but remember, through adding and subtracting, the exponents stay the same. Through adding and subtracting, you should only be changing the coefficients. So we do this again. We have a plus 6y and a minus 4y. Plus 6 and minus 4 is plus 2y. And at the end, we have a 1 to underline it 4 times to show a different term. All we have is a minus 8. There was nothing else to combine. And so in this scenario, we check, did we use all the terms that we had up here? We did. This would be our simplified expression for the product of these two polynomials up top. Okay, so that's the gist. That's essentially what we need to know about adding, subtracting, and multiplying. So we're going to look at a couple of cases here that are considered special. So if we go to the bottom, to the back page of this document, we see some special cases. Are they really that special? No, because we can work them the same way we already have. Now, they're special in the sense that someone has devised a formula that you could follow. It talks about your first term and your last term. So if we take a times b times a minus b, that would mean that the parentheses have the same first term and the same second term, except one has plus, one has minus. A special outcome occurs there. Now, if you're not doing this all the time, day by day by day, multiplying these polynomials is probably not worth your time worrying about these shortcuts. But if you were going to do this every day for a long period of time, maybe it would save you a little trouble. But we won't be in that scenario here. So let's talk about these special products then, 6, 7, and 8. Now 6, you notice, looks just like what we did on the front. You're going to take one set of parentheses times another, and you are correct. That's what we'll do. It's what's going to happen afterwards is the question. So taking these two terms times these two terms, remember 2 times 2, that should give us 4 terms altogether. Let's go through this. If we take 3x times 3x, 3 times 3 is 9. X times x is x squared. And if we take 3x times 5, that's going to give us positive 15x. Okay? And so now we need to do the same thing. We still need to take this negative 5 on the left times the terms on the right. So negative 5 times 3x is negative 15x. And negative 5 times positive 5 is negative 25. And so the only thing left for us to do, we've multiplied, we have our 4 total terms there, is we still need to combine like terms. And you might notice in the middle here, we have a term with an x and another term with an x. What's different though is these two terms are opposites. They are inverses of each other. We have a positive 15 and a negative 15. The coefficients are going to cancel. And so when we add these together, we're going to get 0x. And 0x is just 0, which is not needed. These two terms totally cancel away. So what we see is that those will cancel, and all you're left with is a 9x squared in the beginning and a negative 25 at the end. So that's what makes this product special. We had terms in the middle that canceled. That's all that was special about it. Now, you can notice what made that happen. If you look up here, these two sets of parentheses were copies of each other. They both have a 3x and a 5, but one has a minus sign, one has a plus sign. Anytime we see that, we should expect that terms will cancel. And that's what makes that one special. So what makes the next term so special? Well, the answer is not much, because we see that there's parentheses with an exponent of 2 on the outside. So we think something like really high, I don't know, high tech's going to go on here, but really all we need to do is think of what does it mean to square something, and it is pretty basic. It just means to take a value times itself, take a quantity times itself. So when we see these parentheses squared, really for us that just means that we need to take those parentheses, that quantity within them, so 3x minus 4y times itself. And as soon as you do that, you're going to see that you're just multiplying two sets of parentheses together. For us means that we can just do what we normally do. We need to take everything in these first parentheses times what's in the second set. So we need to take 3x times 3x. And that would give us 9x squared. We need to take 3x times a negative 4y. Okay, so 3 times negative 4 is negative 12. And x times y, those are two different variables. Can't do anything else other than write them as x times y, so xy. Okay, and what we normally do now is we take negative 4y times 3x. So negative 4y times 3x, that would be negative 12. Always write alphabetical order, so we're taking y times x, but we're going to put the x first because it would be first alphabetically. And then we're also going to take negative 4y times a negative 4y. Remember, negative times negative, put that plus 16. And then y times y is y squared. So that didn't seem very different, but you're going to notice here, what makes it special is when you take a quantity times itself, these two parentheses were copies of each other. So during the multiplication process, you're going to notice that at some point, you're going to have terms that are copies of each other, which is what we see right here and here. They don't cancel, they have the same sign, but they are copies of each other. So that's what makes this one special. But for us, we're just going to combine like terms. So we have 9x squared. Negative 2xy minus 2xy is negative 24xy. Remember, we just combine our coefficients. And then we have a plus 16y squared at the end. And there are no like terms there, so we are all finished. And just a side note, we are in standard form because we started with x, the highest exponent on x, and we worked down to our lowest exponent on x, and then to no x's at all. Okay, so you notice 8 has parentheses with an exponent on the outside. It is very similar to number 7. It's just more fun because instead of having two sets of parentheses, we get to have 3. So I hope you're as excited as I am. We're going to write this 3 times 4x minus 7. Sorry about that. That should be a 4x minus 7 times a 4x minus 7 times another 4x minus 7. If two parentheses weren't enough fun, 3 is going to make it even better. Don't worry, we don't do this very often, but just so you know, what you could do is when you need to multiply 3 sets of parentheses, just ignore one of them. Don't even pay attention to this last one. Save it for later. Let's multiply the first two together first. Okay, so let's try that out. Let's take our 4x times the 4x over here. That's 16x squared. Let's take 4x times negative 7. That's negative 28x. And then we still need to take this negative 7 here times that set of parentheses, or times the second set of parentheses. So we take negative 7 times 4. That's negative 28x. Again, if we're multiplying two copies of each other, we shouldn't be surprised when there's terms that are copies of each other. And negative 7 times negative 7 is plus 49. And let's go ahead and simplify this one. So we have our minus 28s in the middle. They don't cancel, they have the same sign. Instead, what we get is 16x squared minus 56x plus 49. But remember, we had a third set of parentheses that we haven't used. So here's what I'm going to do now. I'm going to take what we just got from multiplying our first two sets of parentheses, and I'm going to bring down our second set where we have 4x minus, or the last set, the 4x minus 7. And what we need to do is we still need to multiply what we got from the first two with the third set of parentheses, which we've done before. We're going to take these three terms times those two terms, and in the end, we should end up with 6 terms total. So these numbers might end up getting a little bit bigger as we go. We need to take 16x squared times 4x. That's 64x to the third. X squared times x to the first, remember, add those exponents. 16 times a negative 7 is negative 112 x squared. Right, in the middle here, we need to take this negative 56 times those terms. So negative 56 times 4 is negative 224. And x times x is x squared. Negative 56 times negative 7 is going to give us positive 392. And then x will still be there. And what we still haven't done is we haven't taken this 49 times these terms. So that's the last thing we'll do. We'll take 49 times 4, which is positive 196. So 49 times 4x would be positive 196x. And then 49 times negative 7 is negative 343. And hopefully you can see our 6 terms that are created. 2 in orange, 2 in purple, 2 in green. There's our 6. What we need to do, last thing here, finally we made it, is combine our like. So let's start with our highest exponent and work our way down. We have x cubed here, x to the third, and I don't see any others. So that means our simplified result will have 64 x to the third. And then we go to x squared. So we have minus 112 x squared and minus 224 x squared. That is going to be negative 336 x squared. We have a positive 392x and a positive 196x, which is positive 588x. And lastly, we see at the end, there's just this minus 343 and no terms to combine with it, so we'll keep that here. And that would be the end of that. We've simplified it. So yeah, it takes a little more work there, but if you're just very systematic about it, everything should go okay. So I know what you're thinking, how could it get more fun than that? Well, we're just going to apply this a little bit to a geometric principle. So the very last thing we're going to do here, pretty basic, let's go back to our geometry days where we have rectangles and triangles and just talk about a couple of key things here, perimeter and area. First off, perimeter we know means to add all the sides. And so if our sides happen to be represented by polynomials, we can apply what we did on the front of these notes, which was add polynomials together. So some things to remember about a rectangle would be that the length is the same on each side of the rectangle and the same for the width. And so if we want to find the perimeter here, which means add all 4 of your sides, that is all we need to do. So to find our perimeter, we just need to take our 4 sides, add them together. So 3x plus 2 plus 3x minus 2 plus, we have an x plus 4 and another x plus 4. And you might notice we're adding the same thing. We're adding 2 of the same thing here and 2 of the same thing here. There is a simplified expression for this. It's simply to find perimeter, you take 2 times your length and add that with 2 times your width, which is essentially what we did. We have our length twice and our width twice, which is what this means. So you can use that if you choose. And so if we combine here, we have 3x minus 2 plus 3x minus 2. That is 6x minus 4 from those. Oops. So we get 6x minus 4 from our 2 lengths being combined. And we also have our two widths over there. So x plus 4 plus x plus 4. X plus x is 2x. 4 plus 4 is 8. So the last thing we need to do is combine these two expressions, and we're all finished. 6x plus 2x is 8x, and negative 4 plus 8 is positive 4. Okay, so there's our simplified expression for the perimeter. So if we ever want to know the perimeter, all we need to do is put our x value in right here, and we have it. So for area, similar to what we've done in the past, remember the formula for area is length times width. So just take your length and your width, and it really doesn't matter which one is which. We just need them both. So let's say your length is 3x minus 2 and your width is x plus 4. This expression would read as 3x minus 2 times x plus 4. And that is what we just practiced throughout these notes. So let's take 3x times both terms over there. 3x times x would be 3x squared. And 3x times 4, that's plus 12x. Still need to multiply the negative 2. So we take negative 2 times x and negative 2 times 4. Okay, and don't forget, we always have these like terms in the middle that we need to combine here. So let's go ahead and simplify this just one more time. And we should end up with 3x squared in the beginning. In the middle, we have a plus 12x and a minus 2x. That's plus 10x. And at the end, we have a minus 8. That would be our simplified expression. So if we wanted to know the area of the rectangle, if we know the x value, we can put that x value here, and that would tell us the area. Okay, so one last case would be a triangle. We're going to just find the area of this triangle, and you see that we have the formula here. It should be familiar to you. It's area equals 1/2 times the height times the base, or times the base times the height. A lot of times we see it like this. Area equals, and we had 1/2 base times height. That's pretty common. Sometimes that puts the b and the h on top of the fraction. But let's apply that here. We have our base, which would be a side of your triangle. So here's our base. And our height connects to that through the triangle and technically makes a 90-degree angle right there. So here's our height. That's how you find a base and a height. The height always connects to the base. So for us to find the area here, we just need to substitute into the formula. We're representing 1/2 with the decimal 0.5. And we can start with our base or with our height. It doesn't matter. Order of multiplication does not matter. So if we want to start with the height, we can put a 4x right here. And our base is 2x plus 1. And we have three quantities we need to multiply. We need to take this decimal times these parentheses. So my recommendation might be, how about we multiply our parentheses together first before we start putting decimals into the mix. So if we do that, we're still going to have a equals 0.5. We're not going to do anything with that yet. And there's only one term in these parentheses. So when we take one term times these two terms, we're only going to get two terms from that because 1 times 2 is 2. So let's take 4x times 2x. 4 times 2 is 8. X times x is x squared. 4x times 1 is just 4x. Okay, so we have that now. And to take 0.5 times both of those terms, we're going to distribute the 0.5 through there. And just like before, distribute to all terms in the quantity. So 0.5 times 8x squared is just 4x squared. And 0.5 times the 4x would be plus 2x. Multiplying by 1/2 is the same as dividing by 2. And right there, we have a simplified expression for the area of the triangle, meaning if we wanted to find the area of this triangle, if we know the x value, we can just put the x value here and here, and we have the area.